Hello guys, welcome to another video of strength of material. We are dealing today with the stress and strain relationship between mild steel and HYG steel or carbon high carbon steel or TMT. Those are same because the mark means their grouping are same. Their properties are different, but the main property of them is they are using high carbon. So let us see first. Some basic difference between mild steel and HYG steel. So for mild steel, we are using less than 0.25% of carbon, and for HYSD, we are varying this proportion from 0.25 to 1%, sorry, 2.5%. So as we know that the carbon provides strength to that material, carbon content always providing the strength to that material. For HYSD steel, we are higher carbon content. So let us see first. Okay, see carbon content are varying from 0.25 to 2.5%. And second is the manganese content. Manganese is also very much important property regarding steel because steel is an alloy. So manganese content also less in mild steel. For HYSD steel it varies from 0.2 to 1%. Okay, for mild steel it is less than or equal to 0.4%. General grading of mild steel is Fe250. All know that 250 is the yield strength, and here HYSD are varying from Fe415 to 500. Those are dealing with the yield strength of that bar. So mild steel are generally available for plain bars, 6 mm available, and HYSDR bar having 8 mm dia starting or valid, uh, varying up to number of diameters. So the main property in that HYSD we have corrugation on bar surface. So corrugation on bar surface means there is a hatching on bar which will provide a good bond between concrete and the steel rebars. So again, one of the important bar is TMT. So what is TMT? TMT means thermomechanical treated. Yes, name is thermomechanical treated. Means thermo means heat. The bar is used heat or the heat is used to produce that bar. So the TMT bar is generally designed on two layers. Means the diameter of bar, the section of bar is a single, but they have constructed in two layers and they are very bonded to each other. So first is outer core. Outer core of bar is heated very much and cool suddenly or immerse in water suddenly. So it will give the resistance to the rusting because there wear and tear of the surface. It will provide the very much resistance to that rusting, and the inner core are cool slowly as we put bar in suddenly in water and take it out. So left it for cooling for slowly cooling. It will gain the strength in ductility and toughness. So there is a bar which will provide strength and also provide ductility, also wear and tear resistance. Also, so TMT bar is normally using nowadays for high construction or massive construction. So next is the carbon property. So roll up carbon. As we know that carbon increases, first is the carbon percent increases the first strength, second brittleness of the material, second hardens it hardens, but the main property decreases the ductility, and second is toughness. So toughness and ductility is decreases. Toughness is nothing but resistance to the impact. The impact shown in the for impact resistance shown for the impact loading. So there is basic difference between what is the toughness importance. Okay, let us discuss about the vehicle construction. In India, there is a no branded vehicle. Means Indian brand is also populated, but as we know that the massive brand in world, BMW, Audis, or Jaguar or more brands, they are using their body of vehicle is very costly, and we have not seen much accidental picture of that vehicle that the total car is crushed or total car is crushed between the two wheels, or there is some massive accidental pictures for that cars because they are using the body which have the maximum manganese content. So that's why the cost of that vehicle is so much high, because they are using high manganese steel. That high manganese steel provides the toughness, means during accident there is a rising of much and more impact between two bodies, so it will must be a tough body. So that's why they are increasing the manganese content in the body material of that vehicle. So that's why they have gained the toughness property and have there is a not much loss of the body. So in our Indian vehicle production, that cost is for the middle class persons, and so that's why they are using the normal steel. So that's why it get the dent and the accelerated very muchly, or yeah, they are using the fibers for body nowadays. So let us see. It's not the point, but I will just give the example of toughness. What is the importance of toughness? So let's see what next. Okay, this is a simple and it is a graph we put from the input data. So I have not nominated the points. So let us see the one by one. It is the graph for mild steel stress strain. Before that, I have cleared the one question of I have got the comment. So why we are generating strain on x-axis and stress on y-axis? Let us see, my friend, the product which are independent. That means they are not dependent on another quantity. They are generally shown on x direction. As we know that we have pulling the bar, so we are pulling applying forces. The dimension are actually we have saw they are increasing or decreasing. For a pulling force it will be increasing, for pushing force it will be decreasing. So that dimension change is shown by what? Strain or epsilon. So that's why we are putting epsilon on x-axis and stresses on y-axis. So we have got clear the point. So now start the explanation of that graph. So for loading, from it will be start from 0 and up to that point. That point it will be limit of proportionality. So everyone knows the Hooke's law. Hooke's law is valid between that range only. So up to this point, Hooke's law is valid. Means it is the limit of proportionality. Stress is directly proportional to strain. This is Hooke's law. And second point is what? Up to that point is elastic limit. Means the elastic limit that mean when you release the load on that point, it will regain its original position. But difference between those 2 points is that up to proportionality we have got the same proportion on stress and strain, and up to elastic point we have not valid that proportion. So it just the property that is regain its original position. That's why we have denoted that it will be the elastic limit. And secondly, that point is upper yield point, and another point is lower yield point. So there is a basic difference between upper and lower yield point. So what is upper yield point? Actually, now the elastic region has been ended, and then after it will start in the plastic region. So actually starting of the plastic zone is occurred at that point, upper yield point, but we are taking as a lower yield point because lower yield point is also associated with our yield stress. So why we take that lower yield point? Because the lower yield point value, so the upper yield point value is fluctuated. It may be sometimes coincide near to the lower yield point, or maybe very near elastic, so it will be varied. But the lower yield point have position is fixed and no fluctuation, and have permanent strain of 0.002. So that is the permanent strain of 0.002. So this will be the permanent strain of 0.002. It will be denoted the starting of starting of plastic zone. Then it will be in plastic zone, so the stress remain somehow constant, but the dimension are increasing. So the dimension of that bar is increasing. So that's why we are got increase in what? Strain value. Then again, in this zone, we have material strain hardens. What is strain hardens? So as the strain is increasing, that the dimension is increasing, so we have got the increase in stress value also. So the stress value is also increasing. So why this happened? This happens due to the metallic bonding between the element or the atoms of that material. As metallic bond first slips, they are sleeping, and now the slippage, and then again at some point they are resisting each other. The flow of each element, they resisted each other, and that resistance gains the strength of that material as we are increasing in dimension also. But the that metallic bonding will provide us the strain hardens. So it means there is the increasing stress value, but as well as increasing strain value. Then again, this is the ultimate point. So ultimate point is the point where the maximum stress or the maximum strength of that material, it is denoted by Fu, and then again it start losing its strength, and then at some point it fails. So this curve is for nominal stress strain curve. Nominal means it is using the actual area at each section. So we are dealing with here. So the value found out by using actual area. So what is that? Because it will decreases the value of stresses after ultimate point. So in what is the true stress strain curve? It will be started here and it will be go on increasing and then failure. Okay, as we have the maximum stress at failure because the instantaneous cross section area, the actual cross section area at the time of failure is very much lesser as compared to those sections. So that's why we are getting the lesser cross section area, and as we know that as the cross section area is lesser, the stress value is increases. So that's why we have got for true stress strain curve the maximum stress at the point of failure, and for nominal it will be get at the ultimate. So hope you have got the point. So let us see the next point. Yes, it will be for high carbon steel. High carbon, as we know that high carbon content increases the strength but decreases the ductility. So it will be not gives us the proper graph as for strain as for plastic zone, linear plastic zone, and the strain hardening. So it will be for yield zone. So this point will be up to that point. It will be linearly elastic. So that zone will be linearly elastic. So variation will be linearly elastic, and up to this point it will be elastic, but the variation is non-linear. As we saw that the variation is non-linear, and then at that point we have saw that there is a yield stress at that point at the end of. So for that material, high carbon steel, the Hooke's law is valid up to that point only because it is the linear elastics, and from this zone the Hooke's law is not valid because here is the graph which produces the non-linearity. That's why the Hooke's law is not valid between that zone. So Hooke's law is valid up to that zone only, and at the end of that point, so as the non-linearity ends, we have started that the plasticity. So that's why we are starting the yield, we have got taken the yield point here. So it will be the 0.00000002 strain at here. So that is the difference between the high carbon steel graph. We have got in initial position there is a linear stress strain relationship up to proportional limit for mild steel, but for high carbon steel it will non-linear up to some part and then non-linear. So Hooke's law is validity up to some part. So that is the main difference, and there is much advantages of high carbon steel now they are using thoroughly because we are generally using limit set of design and check for serviceability. So that's why the high carbon steel is used for vital purposes because it will provide strength, and now then we are checking for the serviceability and it will satisfy. So that's why we are using the high carbon steel nowadays. So that's it from the today. Hope you have got the clarity of what is stress strain in high carbon and mild steel. So thank you. We will see the next topic in next video. There are strength of material is a vital topic subject. So hope you have got interest in that, and we will start another lecture with some more important. So thank you.